here comes the Electro Chevrolet. Paul Mangelsdorf, the 1940 Chevrolet Coupe. But it's moving pretty good on the top end. He's going to try to get around Fontaine. He does. 1265 for Mangelsdorf in the electrified 1940 Chevy. That's pretty awesome.
It's just a cool thing because I'm the gasoline forever guy, but I do not discourage this behavior.
So at the end of the last video that you saw, I promised that the next one was going to be testing with the new sport inverter, and unfortunately that's not the case. Shortly after filming that video and first testing the car, I had a fluke failure of the control board in the drive unit. The inductor in the 12-volt supply broke off the board while I was just casually driving the car, and that opened the contactors and killed the sport inverter. Over the next 2 months, I struggled to try to repair the sport inverter, ended up abandoning that, piecing together an inverter with pieces of the base inverter and the sport inverter, getting it in the car on a fluke, not knowing if I was going to blow stuff up or if it was going to work, and it worked quite well. Then I immediately jumped into the thrash of getting the charging system ready to go on drag week, and unfortunately, I didn't film much of that. I was on a very tight time frame to get everything done, and frankly, filming it was not the first thing on the top of my mind. I did get a lot of work done before drag week, and then I got some more work done afterwards, and so now the car is close to fully functioning. There are still some things to fix in control of the AC charger and changes to the curve for CCS, but I got the AC charging working properly for drag week, and I got CCS fixed shortly after drag week. So this video is going to be a summary of the breakage and process of figuring out what went wrong on the inverter, and then the attempts to repair it, and then as much as I can information on the upgrades that I did do to the car. The next video, I can promise you this, is a summary of Drag Week 2024. Once again, the car and I survived and became the first person to complete the event in an EV twice. So I've got first conversion and first time to do it twice. So that'll be coming up in the next video. But like I said, this video is going to be a summary of what went wrong and what I did to fix it and get the car to Drag Week 2024. Basically what happened, and it took some troubleshooting to figure this out, the inductor on the inductor as part of the 12-volt supply circuit on the open inverter board broke off, and that killed 12-volt supply to the board, which obviously opened the contactors and killed that drive unit. So I was headed down a hill, there was energy, it went into and killed one of the IGBTs. This is the component that failed. As you can see, it's broken off, and that is part of the 12-volt supply onto the board. Essentially, 12-volt power runs through this and that before it goes to anything else. So by that breaking, it cut 12-volt power to the whole board. So I have two replacements in case I screw one of them up. So I'm going to grab the soldering iron that I have, try to remove this one, and then put one of these new ones on there, and then I can go test the board and make sure everything powers up properly. So I have the inverter here on my kitchen table that is going to serve as a bit of a clean room as I make the repairs to it. It's turned about 90 degrees from how it is in the car, so these are the bus bars that run over into the motor, and then this is to the outside on the passenger side. To remove it from the car, the current sensor and voltage sensing and distribution bus from this end had to be removed, and then there are numerous screws down in here that had to be removed to remove it from the drive unit case. So what I need to do now is start working on removing the damaged phase of the inverter, which, yep, right here you can see the bubbling from the failed IGBT. I spent about 2 months attempting to take apart that phase and fix it at the IGBT level. I know this has been done before, but it ended up pushing the limits of tools that I had or could acquire and my ability to actually do it. I still hope to fix that phase and put that inverter back together and into the car, but unfortunately I ran into a problem where I'm having a lot of difficulty getting the IGBTs separated from the bus bars so that I can finish the disassembly. Unfortunately, the way that is designed, some of the IGBTs, including the damaged ones, are underneath one of the bus bars, and the only way to remove the bus bar is to desolder those IGBTs. So working through that process, I'm hoping to eventually finish it, but I did have to stop that and put together an inverter that would work. I hoped, and it did. The car now runs in the 11s and has driven over 1,000 miles on this, so it's clearly a good solution. I should explain what the solution is. I attempted to repair the base inverter that I had a bad phase by buying some mixed parts of various states of repair from a friend. Unfortunately, those didn't end up working out. There was one good phase among them, but it had a bad gate driver. Once I put a new gate driver on it, it failed the phase. It was a small-scale disaster. It didn't end up working out correctly. At that point, I had 2/3 of a base inverter and 2/3 of a sport inverter, and I needed an inverter to run the car. What I knew was that the architecture of the two inverters was the same. The gate drivers appear to be the same. The only difference is the IGBTs in the sport inverter are higher power or capable of higher power, and the boards are red in the sport inverter and green in the base inverter because red makes things faster. What I ended up deciding to do was thinking that since all of the phases are getting the same instructions from the control board, and they're of similar architecture, so they can accept the same messages. My line of thinking was that the sport phase, if I added that to the base inverter, all it would be is extra capacity that isn't getting used. Now, if you want to get into the actual electrical engineering of it, there are slightly different turn on and turn off times of those IGBTs. I was cautioned later that this could cause some vibration issues or even blow the base phases. So far, it has not done so. So I decided to take the risk, put a sport phase into the base inverter, put the base inverter back in the car, and see if it would work. It worked well around town. It seemed to be good, so I moved on to fixing the charging system. So I've done a lot of work without the camera on because of the time constraint and rapidly changing plans. Right now, the car has a hybrid inverter in it, by which I mean it has 2 base phases and 1 sport phase. I know this isn't a good idea. I'm not sure how bad of an idea it is, but it does seem to spin the motor, and we're about to take it out on a road test and see if I'm right. If this works, I can move on to the charging system upgrades that I need to do before drag week. And I will come back and put a proper matched inverter back into the car after drag week when I can afford to buy another one. As you may remember from my tale of Drag Week 2023, the Model 3 PCS that I was using was not functioning correctly. I don't know if that was a bad PCS I had, a bad control board, or just an incompatible control board with that version of PCS. All I know is that it didn't work and would only pull 2 kilowatts of power, so it is out of the car. What I wanted to do was try to reverse engineer and use the Chevy Bolt, the full electric one, onboard charger in DC to DC. It appeared that they may be very similar to the second generation Chevy Volt, a hybrid one, and that only needed pulse width modulation to control them. Turns out that was correct. I was able to use a similar control as what Arbor had already figured out for the Volt hybrid ones to control the Bolt. Now, I tried to write an Arduino to control these automatically in conjunction with other parts of the car. That didn't end up working out the way I wanted to, at least not yet. What I ended up needing to use was some cheap pulse width modulation generators from Amazon. I think they were like 10 bucks for 2 of them. One runs the DC to DC, one runs the onboard charger. I mentioned before that I have CCS working now, but I didn't for Drag Week. I went ahead and integrated CCS using the Open Inverter Foki board, or Foki or Foki, or however it's supposed to be pronounced, the fully open CCS charge control interface. That has worked flawlessly since I installed it. It talked to the station, it initiated the charge, everything was great. The problem that I had is that Foki wants to see a current request from something else in the car, and the BMS that I had set up couldn't do that. And so I was working on designing my own Arduino board to take data from the BMS and send a current request to the Foki board. Unfortunately, my coding ability is not great, and so the version that was in it for the one chance I had to test before Drag Week didn't work. Turns out during Drag Week I figured out the problem in the code and had made the adjustments, but didn't have the right computer and cables there to make the change. And so 1 week after Drag Week I was able to make the change to that code, and it's working well now. It's a little late for Drag Week, but we are charging at almost 50 kilowatts on CCS. We are charging on Electrify America. One more station in the books, CCS working well. Also the first time charging next to a Blazer and next to a Rivian. Lots of firsts today. And we are CCS fast charging on an ABB charger here at a Nissan dealership. At this point, with it working on ABB as well as Delta-based EVgo and an Electrify America, I think we can say that Foki works for North American style CCS. The one thing remaining to do on that is to make tweaks to the charge curve. Now that I've tested it on multiple stations and know that it's working well, I want to change it so that it's pulling down more power and it isn't ramping off as harsh. Those were design choices I made when I was writing the code that it turns out weren't the right or weren't the best option for handling it. It's not anything bad, but it is charging slower than I'd like it to. So those are a few things that are going to be coming up next in the upgrades for the car. So the car's not done by any means. As I mentioned, I've got to fix the AC charge control and get that so that's much more automatic. I've got to make some tweaks to the charge algorithm for CCS so that it's putting in a bit more power both earlier and later in the charge sequence. And then I have a lot of other little things to fix as well as little things to tune. I want to fix the battery cooling and heating situation. I think the the car could do to have both cooling and heating capabilities there, even though I'm not seeing much temperature rise when fast charging or on the track. I would like to be able to control that a bit better. Also in the tuning, I need to figure out why safety keeps getting tripped sometimes and not others. So I'm planning to upgrade the firmware of the inverter so that I can use the remote access to it better, and data log on some passes and see what exactly is happening. Where is it pulling too much power or not enough power, and how can I improve it? I think with this inverter that's in there, this hybrid inverter, I can probably get down to about 11.5. After that, I'm going to need a full sport inverter to get this into the 10s. But that is a long-term goal for the car. There are a few other gremlins, like a fender that rubs during launches, and the usual rattles and shakes and other things that I need to get rid of. But overall, the car is running really well. I had it out for a cruise this weekend, went about 100 miles, testing the CCS charging, going to a cruise in, overall having a good time. So I'm really happy that the car came home in one piece and is running well. I've got a good tune for getting into the 11s, and I've got a good street tune for it, and now it's about making those tunes a little better, making the car a little more livable inside, and overall just having fun with my car. Once again, something I said in my drag week recap, which I think is going to come out after this video, I really hope you get out and have adventures with your car, and I hope I'll see you out there. Oh, and one more thing. I ordered this before drag week, but it didn't show up until a couple days later. I think it's fitting. This is annoying, trying to film outside, but I didn't want to film inside if the car works. So